Solving recurrence relation through substitution method. Suppose we have this recurrence relation. So how we are going to solve it? We are going to write Tn is equals to Tn minus 1 plus 1 by n. Then in the next step, what will happen? It will convert Tn minus 2 plus 1 upon n minus 1 plus 1 upon n minus 0. For n, we can write n minus 0. So in the next step, what will happen? It will be like this: Tn minus 3 plus 1 upon n minus 2 plus 1 upon n minus 1 plus 1 upon n minus 0. So if we do like this up to n minus 1, then what we will get? We will get T n minus 1 plus 1 upon n minus 2 plus 1 upon n minus 3, and so on. It will be like 1 upon n minus 1 plus 1 upon n. So what we will get? n cancel by n, so we will get 1 here n cancel by n. What we will get? 1 by 2. Like that we will get 1 by 3, and so on. We will get 1 by n. So for 1, which we get from here, we can write 1 by 1. So that will be equals to order of log n base 2. So this is the solution of this recurrence relation by substitution method. Now move to the next. Suppose if we have this recurrence relation, Tn is equals to 1 if n is equals to 1, and Tn by 2 plus c if n greater than 1, where c is an constant. So how we are going to solve it? First we write Tn is equals to Tn by 2 plus c, and after that what we can write? We can write Tn by 4 plus c plus c. So for this, how we can write? We can simply say this is 2 into 1 and this is 2 into 2. So we can write like this: T n upon 2 to the power 2 plus 2c. We can write like this. So for next, what we can write? We can write n upon 2 to the power 3 plus 3c. So like that it will go. So if we go up to 100 times, then what we will get? We will get T n upon 2 to the power 100 plus 100c. And like that if we go up to k time, then what we will get? We will get T n upon 2 to the power k plus kc. So for this, how we can write? N upon 2 to the power k is equals to 1, then n is equals to 2 to the power k. Then if we take log, then log n base 2 is equals to k. So we can write here like this: t to the power n upon 2 to the power log n base 2 plus c log n base 2 instead of k. So we can write like this also. We can exchange this. We have the formula. We can exchange this to this. So we can write n log 2 base 2 with the formula c log n base 2, which we discussed earlier also in other lectures. So what will come here? Log 2 base 2 will be 1. So this will be n upon n. This will be 1 log 2 base 2 plus c log n base 2. So what it can be? It will be 1. It will be c log n base 2. N will be divided by n. So this will be 1. This will be log c log n base 2. So this, the order will be order of log n base 2. So this is the solution of this substitution method. By substituting the value, we can find out the order of the recurrence relation.